Hi, hello. This question is from electromagnetic induction. A long solenoid with 15 tons per centimeter has a small loop of area 2 centimeters square placed inside the solenoid normal to its axis. If the current carried by the solenoid changes steadily from 2 amperes to 4 amperes in zero point 0.1 second, what is the induced EMF in the loop while the current is changing? First, we need to understand there is a solenoid with some dimensions are given, that is a 15 tons per centimeter, and in which the current changes from 2 amperes to the current flows, that is changes from 2 amperes to 4 amperes in a time 0.1 second. This is about the solenoid. Inside a solenoid there is a small loop is placed whose area is 2 centimeters square and which is placed normal to its axis. Solenoid loop normal is placed inside the solenoid normal to its axis. That is, for suppose this is a solenoid, this is solenoid. Let's say current flows into the solenoid, current flows out of the solenoid in this direction. There is a small loop, there is a small loop is placed like this, whose area is, its area is A. So the what is the question? That is, what is the induced EMF in the current in the loop while the current is changing? So as the current flows through this solenoid changes, the solenoid generates a uniform. Usually when current flows through the solenoid, the solenoid generates uniform magnetic field inside it. As as the current as the current flows through the solenoid is changing with respect to time, then the magnetic field generated by the solenoid inside it changing with respect to time, so that the magnetic flux that is passing through this loop placed inside the solenoid is will also change. This leads to generate the EMF across the ends of the loop according to Faraday's law of electromagnetic induction. So that EMF can be written as E equal to minus N into number of turns in the loop d phi b by dt. There is a phi b is the rate of change of magnetic flux through the loop d phi b by dt. Phi b is the magnetic flux that is passing through the loop. Therefore, EMF that is generated, that is across the loop as the current passing through the solenoid is changing, that is minus form N d phi b by dt. The number of turns in the loop equal to 1. Therefore, induced EMF equal to minus d phi b by dt. What is the flux magnetic field generated by the solenoid? That is mu naught Ni. Ni. What is flux passing through the loop? B bar dot N. Since this is A bar, that is A into N cap, and it is also B bar. Hence, flux equal to BA. Again, phi equal to b in b bar dot a bar. Since b bar and a bar are same for the given loop, b bar dot a bar becomes ba, and the area of the loop is constant. Then take d phi b by dt equal to d by dt of b into a. Since a is constant, you can separate it from integration differentiation. Then a into d by dt of b. Then what is b? Mu naught ni. Mu naught ni. Now substitute the b value in this. Substitute here. You will get e equal to d phi b by dt equal to a into d by dt of mu naught ni. Then mu naught and n are constants. Mu naught is the permeability of the medium free space, where n is the number of turns per unit length in the solid. You can these are constants. You can separate it from the differentiation. A mu naught n equal to di by dt. There is something. If the current carried by the solid changes steadily, that means di by dt equal to delta I by delta t.